Welcome back everyone. In this video we're going to learn about probability. Here we'll be discussing the formula and we'll be looking at some numericals to understand the concept better. So without any further ado, let's get started. The word probability or chance basically tells us how likely an event may or may not occur. Like for example, if we say that there is a 70% chance that it will rain tomorrow, so it is very likely that it will rain tomorrow. If we say that there is a 100% chance that it will rain tomorrow, that is, we are very much sure that it's gonna rain tomorrow. If we say that there is 50% chance of raining, then we know that it may rain or it may not rain. That is, the outcome that it may rain is as likely as the outcome that it may not rain. Fine. So let us understand the word outcome. Outcome is basically what we get finally, okay, or what is the possible event that will occur. For example, let's say you have a coin. Now we know that a coin has two faces, that is head, and on the back you have tail. Now when you toss the coin, the outcomes can be either head or tail, right? We obviously here we're ignoring the fact that the coin might just land on its edges, right? Neither flipped down, neither flipped on top, but right on the edges like this, right? Standing. So this is ignored. So the only other possibility is either head or a tail. So that is the meaning of outcome. Now that brings us to the word sample space. Okay, the set of all the possible outcomes means if you collect all the possible outcomes of an event, then this set is called your sample space. For example, for a coin, the possible outcomes are head or tail. So if you put it under set, this is how you actually draw sets, two curly braces, and whatever is inside it are called elements. And if you roll a die, then the possible outcome is you might get either 1, 2, 3, 4, 5 or 6. You cannot get 7, 8 and so on, and you can't even get 0, right? The numbers are only 1, 2, 3, 4, 5, 6. So if you make a set out of it, then this will be the sample space for rolling of a die. Okay, let us now discuss the main formula that governs the whole chapter. So P stands for probability. Okay, probability, this means of, so probability of an event is equal to number of favorable cases, okay, the cases that you want to happen, divided by total number of possible cases, okay, or number of possible cases, and the possible or the probability of an event. Now this bar means not, okay, so probability of not an event, that is an event not happening, is equal to number of unfavorable outcomes or cases divided by total number of possible cases. Okay, if you solve this, you will get 1 minus probability of an event. So we can say that probability of an event, okay, if this is probability of event not happening, so this is probability of event, in short, is plus probability of an event not happening is always equal to 1, right? If you take this here, then minus becomes plus, so you get probability of not event and probability of event is equal to 1. Now this is very important. We have to know that probability of an event or a probability of not an event, basically probability of anything, will always be greater than or equal to 0, and it will be always less than or equal to 0. That is, a probability of any event cannot be negative, okay, -1, -2 and so on, and it cannot be more than 1, that is, it cannot be 2, 3 and so on. Here we will learn how to draw the sample space when you have multiple number of coins. Okay, let's say instead of simply one coin, you have two coins. Okay, then what do is we write the first coin, that is head tail. Even in the second coin, the possible outcome is head tail. Fine. So what do is, first of all, we take this as our constant, then we join or merge it with each one of them. So the first one is head head, then head tail. So head head, head tail. Since we do not have any more options, we take this as constant now, then we take with each one of them. So we have tail head and tail tail. Okay, let us understand this better with the help of example, that is 3 coins. So again we do the same thing, head tail, head tail, head tail. Since there are 3 coins, we'll write it 3 times. Then we will take this to be the constant, then we will come to the next level, then we'll keep this to be the constant since we have choices. Now since we don't have any more choices, we will merge this 2 with this and then with this. So we get head head head, so head head head, then head head tail, so head head tail. Okay, since we are out of option, now we're going to take this as our constant and we're going to merge with each one of them. So you have head tail head, head tail head, head tail tail. Okay, then since we're out of option again, now we're going to take this to be our constant since we're done with this, then we'll merge with this as our constant again and we'll do with this. Basically we'll repeat everything again. So tail head head, tail head tail, we're done. Then we take this to be our constant, tail tail head, tail tail tail, and this is what you'll get. Okay, how do we know whether we have taken all our options? This is the formula. Basically if there are 3 coins and each one has 2 options, right? So it'll be 2 into 2 into 2, 2 into 2 into 2 is 8. So let's count 1 2 3 4 5 6 7 8. Correct. Here we have 2 coins, so 2 into 2, so 2 into 2 is 4. Let's count 1 2 3 4. In case we have 2 dice, okay, then the sample space will be drawn similarly. So 2 dice means in the first option you have 1 2 3 4 5 6, the second one 1 2 3 4 5 6. We're going to do the same thing as we did with the coin. First of all, we're going to take this to be our constant and we'll merge with each one of them. So 1 1 1 2 1 3 1 4 1 5 1 6, right? So this second one, since we're done with this one, we'll take this one. So again 2 1 2 2 2 3 4 5 6. So with 2, similarly with 3 4 5 and 6, and this is what you'll get. Okay, again to check, the first die had 6 possibilities, into second die also 6 possibilities, so 6 into 6 is 36. So basically there should be 36 possible outcomes. Let us see some numericals now. So the question is shown on the top of your screen. In a cricket match, a batsman hits a boundary 10 times out of 60 balls played by him. Find the probability that the boundary hit by the ball. Fine. So here the number of favorable outcomes is equal to 10, right? Because our favorable outcome is hitting the boundary and he hit the boundary 10 times. So our number of favorable outcome will be 10, whereas the total number of possible outcomes will be 60 because he played 60 balls. So the maximum number of boundaries that he could hit was definitely 60. Alright, so possible 10, I mean favorable 10 and possible 60. Therefore probability of boundary is hit is equal to, you'll have to write the whole formula every time. So number of possible outcomes divided by total number of possible outcomes, sorry, number of favorable outcome divided by total number of possible outcome, which is 10 by 60. 0 0 will get cancelled, you'll get 1 by 6. Let us see another question shown on the screen. 3 coins are tossed simultaneously 100 times. The following outcomes are recorded as outcome 3 tails, 2 tails, 1 tail, no tails. The frequency for 3 tail is 23, 2 tails 28, 1 tail 23, and no tail is simply 26. So number of favorable outcomes will be 28 plus 23, right? Favorable outcome is more than 1 tail, right? More than 1 means either 2 or 3. So if you remember, for 2 it was 28 and for 3 it was 23. So 28 plus 23 is 51, and since the coin was tossed 100 times, the total number of possible outcome is nothing but 100. Therefore probability of coming up more than 1 tail is equal to number of favorable outcome divided by total number of possible outcome, that is 51 by 100, which is 0.51. Let us now look at the question shown on the screen. The probability of getting the correct answer to a certain question is x by 2. if the probability of not guessing the correct answer is 2 by 3, find x. Okay, so it is given that probability of guessing the correct answer is x by 2, whereas probability of not getting the correct answer, okay, we will not be writing not guessing, but we will be using the symbol not. Okay, probability of not guessing the correct answer is 2 by 3. Now the second formula, we know that probability of an event, that is guessing the correct answer, plus probability of not an event, okay, that is not guessing the correct answer, is always 1, right? So if you substitute, you get x plus 2 by 3 is equal to 1, which if you solve, you will get x is equal to 2 by 3. Fine. Let us look at one more question. An integer is chosen from 1 to 100. Find the probability that, number 1, integer chosen is a prime number. So first of all, what we will do is we will write down all the prime numbers from 1 to 100. So these are it. Okay, if you count, then you will get it to be 25. So number of favorable outcome is 25, and total number of possible outcome is 100. We know that from 1 to 100 there are 100 numbers, so total 100. Therefore probability of integer chosen is prime will be total number of possible outcome, remember in the exam you'll have to write full, divided by total number of possible outcome is equal to 25 by 100, which if you cancel you get 1 by 4. Let's do the second one. The second one was integer chosen as a composite number. Now if there are 25 prime numbers, then there has to be 100 minus 25, okay, plus 1 composite numbers, because this 1 is neither prime nor composite. Okay, so we can't count this. So 100 minus 25 is 75, and this minus 1, so minus 1 will be 74. Therefore number of favorable outcome is equal to 74, and total number of possible outcome is equal to 100. Please remember, again you'll have to write full. Okay, therefore probability of integer chosen is composite is equal to number of favorable outcome divided by total number of possible outcome, which is 74 by 100, which is 0.74. Okay, the third one is you have to find the probability of the number being a multiple of 11. So from 0 to 100, these are your multiples of 11: 11, 22, 33, 44, sorry, not from 0, 1, 55, 66, 77, 88 and 99. So if you count, you'll get 9. So number of possible outcome or number of favorable outcome is 9, and total number of possible outcome is 100. Therefore probability of getting a multiple of 11, again you'll have to write down the formula, that is number of favorable outcome divided by total number of possible outcome is equal to 9 by 100, which is 0.09. Let us do one more question shown on the screen. So a table is given where age in years is given: 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60 and 60 to 70. The corresponding number of patients is given to be 90, 45, 65, 80, 50, 30 respectively. You have to find the probabilities. Okay, so let's do one by one. So in the first question, you have to find the probability of getting a person who's 10 years or more. Okay, so from the table, number of possible outcome will be 360, because everyone is more than 10 years, right? So number of favorable outcome will be 360, and total number of favorable outcome will always be 360. So probability of this, in the formula if you substitute, you get 360 by 360, which will get cancelled and you'll get 1. For the second one, that is probability of getting someone who's less than 10 years. Now it started from 10, so obviously there will be nothing before 10, right? So number of favorable outcome will be 0, and total number of possible outcome will be 360. If you substitute, you get 0 by 360, that is 0. For the third one, you have to find the probability of getting 3 years or more but less than 40. That means only this category, that is 30 to 40, right? More than 30 but less than 40. So 30 to 40. Now 30 to 40 was simply 65. So total number of favorable outcome is 65. Total number of possible outcome is 360. If you substitute in the formula, you get 65 by 360. You can cancel with 5 and you get 13 by 72. Fine. Let's look at the last one. The probability of 50 years or more but less than 70. So more than 50, okay, but less than 70 means 50 to 70. That is 50 to 60 plus 60 to 70. Now 50 to 60 was 50 and 60 to 70 was 30. So the number of favorable outcome will be 50 plus 30, which is 80, and total number of possible outcome will be 360. Therefore, probability of this will be, in the formula, if you substitute 80 by 360, 0 0 cut, you can calculate 8 and 4 9s are, so you get 2.8. This is the conclusive video of the chapter probability. So please make sure that you practice maximum questions possible, as this is the easiest chapter you will find. So thank you everyone for watching. I hope to see you in my next video. Take care everyone.